Hi guys, welcome back to Physical Science with Mr. Hescox. We are in Chapter 5, we're on Basic Principles of Chemistry. Today we're going to talk about the history and the gentleman who came up with the different models and development of the idea of the atom. If you had to tell me the definition of an atom in 5 words, could you do it? You know, most people say basic unit of matter. That's only 3 words. I like basic unit of matter, indivisible, and small. Very, very small, indivisible. So you don't have to make a sentence for that one. All atoms make up matter. So matter is made up of the smallest forms of atoms called matter, called atoms. The ancient Greeks actually came up with the idea of the atoms. This is Democritus. Democritus went against Aristotle's teachings. Aristotle said that everything was made of fire, air, water, and ether, which was the energy that made us alive. But today we know there are 100 atoms, over 100, about 118 to be exact. Democritus was going against Aristotle's lessons, and he basically said that if we took a loaf of bread and broke it and broke it and broke it and broke it and broke it, eventually you would end up with one atom of bread, which was indivisible. The Greek word atomist, or atomos, excuse me, means indivisible. Let's talk about some of the more modern, but not that soon. So John Dalton basically studied atoms, and Dalton came up with a theory that atoms of different elements are different, like no duh, but basically if you have two different types of elements, their atoms are going to be different. He also came up with the idea that when you combine two elements or two atoms, you can make compounds. Now that was a big deal because we didn't know, bread itself is not a compound. Bread is made up of different types of sugars and things like that. J.J. Thomson was another chemist, and he had gases that he ran electricity through, and he found that it gave off negatively charged particles. So if there's negative particles, he figured that there absolutely has to be positively charged particles because you can't have a negative and a positive. He called his theory the plum pudding theory. Basically, you have a whole bunch of negatives and positives in one atom. We know it's not quite that way. He knew that there had to be a positive charge because we found the electric negative charges. There has to be a mass, and basically he didn't have a whole lot of proof other than he knew that there were negatives and there had to be mass. But it did show us that there were negatives and positives, and that led us to Ernest Rutherford. Rutherford's one of my favorite scientists. He ran his famous experiment by firing positively charged particles at a very, very, very thin sheet of gold. Gold can be pounded thinner than any other metal. Gold is very, very, very malleable, meaning to be pounded thin with a hammer. You can pound gold so thin that it's only a few atoms thick. I know my grandmother used to have dishes that had gold around the rim. It was remarkably thin. You could almost scratch it off. Once he had that, he shot positively charged particles at it. When he fired these positively charged particles at this sheet of gold, he found that most of them went straight through. Some of them deflected, and some of them bounced back. So there's my thin, thin sheet of gold, and he had a box, basically in a radioactive decay, and it fired particles. And on the other side, over here, it would measure the particles. Most of the particles came in contact straight into the film that he shot them into. What he found was occasionally a particle got kicked one way or the other, but not very often. Most of the particles went straight through. And every once in a while, there would be a stray particle kicked back. Now, what Rutherford came up with was basically the idea that the atom is mostly empty space, and the rest of it is a nucleus that is positively charged. What was happening, he was firing these positively charged particles were being basically repelled from other positively charged, because positives repel other positives. So after Rutherford, there was Bohr, and Bohr came up with the idea that you could have this positive nucleus. You have a positive nucleus and predictable areas around the outside where the electrons might be. That's called the Bohr model. And it goes on to the wave model and things like that. But for our purposes, once we get to this model of the atom, we should be good. I'm going to take a break here because the video is starting to get too long. The next video I make will be part 2 of chapter 5, section 1 on parts of the atom. Until next time, be good, be safe. Check back with me, Mr. Hescox. See you later.